Okay, great. Thank you very much. Okay. Now we have seen that, of course, we have done several modules, and in this module, we'll be talking about calculating the process sigma at any point in time during the measure phase. Okay. What does sigma means? Okay. What does sigma means? All of you type variation in the chat box. Of course, sigma is a Greek letter word, but variation is a key. So you need to reduce the variation. You need to reduce the variation. Fantastic. Now, how much sigma level that a process has is what we are going to find out. So we have been collecting the baseline data on the defects. Okay. I'm going to take one practical example of invoice processing, which is very common. Okay. Which is very common. I want to take a transactional process today. And then once we take the data on defects on the invoice or whatever, that example that I'm going to take now we need to analyze for the special causes. In the earlier session, we spoke about the special causes and common causes. Okay. And then in the last previous modules, we have extensively spoken about frequency diagrams, Pareto analysis. Okay, frequency diagrams, Pareto analysis. And we have given, in the last session, I've given various examples and applications of the Pareto chart. And in this session today, we are going to calculate the process sigma. And in the upcoming session, we will go into the detailed process maps. Okay. Now, let us go ahead and try to calculate a process sigma. And before that, I'll give you a scenario. Okay, now I'm going to introduce you to some sort of graphs. Okay. All of you type BSC in the chat box, bell-shaped curve. Okay. And in this bell-shaped curve, you will notice something called as a mean, lower specification limit, upper specification limit. Okay. And if you notice here, all of you type RTY in the chat box. I'm going to introduce some terminologies. Okay. Whether you understand or not, that's different. Okay. RTY, rolled throughput yield. Okay. If I talk about rolled throughput yield today, you will run away from this session. Okay, so I'm going to slowly and steadily talk about very, very simple things so that it is very interesting to you. Okay. So this is either if it is a continuous data where you produce some components, where you see the weight of the component or a diameter of the component, you can calculate what is the capability of that. Or you can even do it by finding out the yield of each and every process. Here you see the overall process, it is a customer specification. Okay, this is a customer specification, whereas here in each process, you have process specification. Each process, there is a process specification. And all of you would agree that every process has got a process specification. How many of you agree? Please type agree in the chat box. If there are 1, 2, 3, 4 processes, each process has each process has a capability. Each process has a capability with respect to. Now, what would happen? I'll tell you. If you go through this process, many products might go through this process, but there might be some defective that will come out of the process. And whatever is the remaining will go through process 2, and there can be some defects that come out of process 2. And remaining products goes to process 3, and there will be defective that comes out of process 3. And remaining products will go to process 4, and there will be defective that will come out of the process. If this is clear on a scale of 1 to 10, please give me 9 or 10 if you are super clear about what I've explained. Okay, now is a game on. Okay, now is a game on. I'll tell you. Now, if you look at this, every process has a capability. So first pass yield, okay, first pass yield, it passes through the process. Based on that process capability, there will be, let us say, 95% has gone through it. Okay. For a simplest of calculation, I will take two processes. In the first pass, 90% passes through. In the second pass, 90% passes through. So what will be the rolled throughput yield of the process? Please type in the chat box. This is just a common mathematics, okay? In the first process, 90% passes through. The second process, 90% passes through. So what is the overall? So if there are 10 processes, each of them at 90%, if there are 10 processes, each of them at 90%, what will be the final output? Any of you can guess? If there are 10 processes, each of them at 90%, what is the final rolled throughput yield of the process? Okay, there are various. So the answer is 0.9 into 0.9 into 0.9 into 0.9 10 times. That's the answer. Okay. If 0.9 into 2 times comes, it becomes 0.81. If it comes 3 times, it becomes 0.72. All right. Okay. We'll go deeper into the examples. Don't worry about this. We'll go deeper into this example at the later stage. Okay. Now I'm going to start with something very, very simple. Okay. We will take an example of this throughput probability maybe in the next session, so that step by step I will explain you. But in this session, what I want to explain you is certain terminologies before I go into the throughput yield concept. Okay. All of you type DPMO in the chat box. DPMO in the chat box. And this is one thing, most of the people are scared, but when you understand this, in this session, you will never going to forget that in the rest of your life. Okay. Okay. So this DPMO, you can write in your notebooks, is defects per million opportunities. So there are 4 words that I've chosen here. One is called defects. One is, okay, per million and opportunity. So let us look at 2 keywords here, defects and opportunities. Okay. So before we get into that, all of you take in your notes, there is something called as units. Okay. For example, one product that you take is 1 unit. Okay. If you produce some nuts and bolts, okay, let's say you produce a nut. If you produce 1,000 nuts, it is 1,000 units. Okay. And every nut or a bolt may have various parameters or specification which the customer will check. Okay. Suppose he wants the diameter to be, okay, let me ask you a question. Suppose if you are buying, say, let's take a very simple example. Okay. If you're buying a ring like this, what are the things that you look for in this ring? Okay. What are the things that you look for in the ring? The size, the metal, the quality, the diameter, the carat, the thickness, the quality, finish. Okay. Okay. The looks and stuff like that. Okay. Now, the point that I'm trying to say here is, whichever is important to the customer, that comes as a specification in the product, and that is an opportunity to become a defect. That is an opportunity to go wrong. Okay. How many of you are clear? If you're clear, I want you to type SC, super clear, in the chat box. Anything the customer is very particular about, if not done properly, it is an opportunity to go wrong, and that is why it is called as opportunity. Okay, super clear, very good. Okay, don't worry if for those who did not understand, I will give you some examples, you'll become more and more clear. And if that opportunity, for example, if this is the ring and if this diameter is undersize or oversize, if it is oversize, if the inner diameter is oversized, it will become loose, or if it is undersized, it will not go inside. So it is called as a defect. Okay, defect is very simple to understand, and this diameter is an opportunity that can go wrong. Okay. Okay. So total opportunities, all of you type TOP in the chat box. Total opportunities. I will introduce you to some terminologies. Okay. Total opportunities. Total opportunities. And all of you type DPU in the chat box. Defect per unit. Okay. Defect per unit. DPU. Okay. Please take good notes. That's very, very important portion. And if this concept is clear, rest of the Six Sigma things will be very clear. And all of you type DPO in the chat box, which is defect per opportunity, and finally defects per million opportunity, DPMO. Great. Okay, fantastic. Now, we have seen slowly, step by step, what is a unit? What do you mean by an opportunity? What do you mean by a defect? And we will calculate total opportunities, defects per unit, defects per opportunity, and defects per million opportunities. We'll calculate all that. And then finally, after getting the DPMO figure, after getting what is called DPMO, we will be able to tell from a table what is the sigma capability of that process. Okay, let us go a little deeper. I'll give you the simplest of example. Okay, now total opportunity is a simple mathematical calculation. If you have 1,000 units and each unit, for example, for this ring, if the weight of the ring and the inner diameter of the ring, then it is 2 opportunities. And if there are 100 units of that ring that I have bought, what is the total number of opportunities? 200, right? So 100 of such rings. And for me, what is important is the inner diameter and the weight of the ring, because it is gold. Okay. So the total number of opportunity is this thing. All right. Fantastic. Now, defects per unit. I have told you there are some 100 units of that. Okay. And if I have 10 defects, okay, if I have 10 defects and 100 units, okay, please type what is the defect per unit. I have 100 units of this and I have 10 defects. So what is the defect per unit? 10 defects, 100 units, 10 divided by 100, okay? I'll give you an example, don't worry. I'll give you an example. Now I'm asking you to calculate yourself, but then I'll give you an example so that it becomes very easy. Defect per opportunity. Now in the first thing, total number of opportunities you have seen, 100 units and 2 opportunities and 200 total opportunities. Now there are 10 defects, I said. What is the defect per opportunity? Defect per opportunity. So 10 defects and total number of opportunity is 200. So 10 divided by 200 opportunities. Okay. So these are the initial calculations I'm just telling you, but don't worry, I'll be giving you an example which the calculations will be shown here. And then 10 defects and total opportunity is 200 into 10 power 6 is million opportunities. Okay. And then you will calculate the sigma capability from a data. Okay, now we will go into a very practical example. How many of you are ready? Just type ready in the chat box, fast. All right. Fantastic. I find a lot of people charged today. Very good. Let us take a very, very simple invoice. Okay. And I'll help you calculate step by step all this. Now, if I have this invoices, units is nothing but the number of invoices that I have. Okay. A unit is any item that is produced and is liable for measurement or evaluation against a set criteria. Okay. So invoice is a unit because it is liable for measurement and evaluation because invoice should be correct. Okay. So that is why this is a unit. Okay. Invoice is a unit. We'll take an example. Now, I want to ask you a question, okay, which all of you can answer. In what ways an invoice can go wrong? Okay, those of you who know about invoices can answer. What ways, what are the mistakes that you can make in the invoice? What are the important things in an invoice? Total amount. What are the important things? Date, address, quantity, units, GST calculations, number of units. Okay. There are many things that can go wrong, right? And so, all right. So, and each of that which is important in that invoice, see, invoice, there is also a line also, okay? In the invoice, there can be some line and there can be some borders. And so we are not going to take that as an opportunity, but the item, the quantity, the invoice number, the invoice date, the GST, the customer name, etc., etc. Those are all, they should be correct. They should not go wrong. So each of them is called as an opportunity. Okay. For example, name and address, contact details, invoice number, item description, quantity, cost per unit, total amount. Let us take these things. Okay. Let us take these things as important for invoice for the sake of example. And these are all called opportunities. Okay. How many of you are clear about this? Type SC super clear in the chat box. Okay, fantastic. So opportunity means the area where defects could be produced. In a very simple language, the area where defects could be produced. Okay. So chances in a unit to have a defect. That is one more way of talking about the opportunities. Okay, now let us talk about a defect. What is a defect? Defect is very simple. Like something which has gone wrong is defect. And a defective invoice can have many defects. Suppose the invoice has got 4 defects out of this 8 opportunities what we have, it is called as a defective invoice. Okay, a defective, how many of you are clear about this? An invoice can have 1 or more defects, and that is a defective invoice. Okay. Super. Okay. Okay. So somebody has typed everything might go wrong. Yeah, it might. That is called as an opportunity. Okay. That's how the terminology that is used here. Okay. A defect is nothing but a discrepancy in an operation or on an item not meeting the specification. So we wanted it to be a particular specification. If it doesn't meet the specification, it is called as a defect. Let's say there are 10 defects there. Okay, let's say that totally we find 10 defects in the invoice. Now, total opportunities. Okay, total number of chances out of all the units to have defects. Okay, that is number of units. Suppose if you have 1200 units and there are 8 type of defects that we saw. Okay, so what is the total number of opportunities? Please type in the chat box. I've already given the answer. You can type in the chat box. 8 different types of opportunities are there. That is called as a defect type. Okay, and 1200 invoices are there. So totally we have 9600 Okay, so opportunities must be very, very clear. That is 8 ways in which an invoice can go wrong. And those are all called opportunities. And 1,200 such invoices are there. And hence it is 9,600 opportunities. Okay. Next, defect per unit. Let us say we had, I think we said we'll have 10 defects, right? And we have 1,200 invoices. We have 1,200 invoices. Now, defect per unit. One invoice is 1 unit, and we have 10 defects. So per unit, we have 10 divided by 1,200, which is 0.0083. How many of you are clear? Type clear in the comment box. This is defect per unit. I'll help you do this in the Excel sheet also. Okay. Great. Okay, Mr. Abhijit has written up to DPMO. Very nice. And Mr. Abhijit, you can also put the sigma value. Okay, great. Okay, let us go to the next step. So defects per unit. Defects per unit is nothing but total number of defects found in the sample by total number of samples, the sample size. Okay, 26 defects found on 10 units of product. So the defect per unit. Look at this. There are 26 defects found in 10 units of product. So defect per unit is 26 divided by 10, which is 2.6 defect per unit. 26 divided by 10. Okay, this is an example of defect per unit. Defect per opportunities. Okay, defect per opportunities. So if you see here, the total number of opportunities we know. For example, if there are 8 opportunities, 1,200 pieces, 1,200 into 8 is the total number of opportunities, and there are 10 defects, it is 10 divided by that 9,600, what we put. Okay, how many of you are clear about this? Type clear in the comment box. We said 10 defects, and total number of opportunities, we said 1,200 invoices, and each invoice has got 8 opportunities. And so 8 into 1,200 was 9,600, which is the total number of opportunities. And the defects, we found 10 defects in the invoice, and hence it is 0.001041. Now we have come to a last step of calculating defects per million opportunities. It's very simple. Whatever that we have calculated in the earlier step, we multiply that by 10 power 6. That is 1 million. Okay. So when we multiply the earlier step by 10 power 6, we get 1041. Okay. How many of you are clear about this step? Type SC, super clear, in the chat box. So how many of you want to see this in the Excel sheet? Excel sheet is very simple. I will revise that in the Excel sheet. How many of you want to see that in the Excel sheet? Type Excel in the comment box. Okay, fantastic. I'll show you in the Excel sheet also. Just hold on. And just for the sake of saving time, what I've done is I've already typed that for you parallelly, and I will show that. So those of you can see the Excel sheet, type ICS, I can see in the chat box. Okay, fantastic. Super, very good. So if you see invoices, there are 1,200 invoices, and opportunities I've written here, okay? That is, there are a lot of invoicing errors that can happen. Name and address, contact details, invoice number, item description, quantity, cost, total amount. These are the opportunities. There are 1,200 invoices, and there are 8 opportunities. Like all these 8 opportunities are written here, and there are 10 defects. Okay, so these are the basic data. Okay, this is 1, 2, and 3. So total number of opportunities is nothing but, if you see here, we have 1200 units and 8 opportunities. And so D4 into D3, which is 9600. Now we are going to defect per unit. Okay. We have 1200 units. Okay. And we have 10 defects. So we will put 10 divided by 1200, which is 0.008333. Okay. So this is defect per unit. So you have defects here, you have units here, which is the number of invoices, and you have defect per unit. And opportunities, total number of opportunities you have calculated is 9600, but defect per opportunity, 10 defects are there. And then I wanted to calculate with respect to total number of opportunities. So defects per opportunity, 10 defects are there out of the total opportunity of 9600. So I have this number here, which is 0.00104167. And defects per million opportunity is 1400, because I've just multiplied this by 10 power 6. Okay. So for those who are very clear, give me a 9 or 10 on a scale of 1 to 10 if you're super clear. All right. Thank you very much. I'm glad that so many of you are super clear. Okay. And somebody is asking me for joining to Lean Champions group also. Let me just share that link also. Okay. Okay. If you're not able to join this Lean Champions group, if the link is not working, copy this link inside Telegram and it will open from inside Telegram. Okay. Now, very, very important step. And how many of you are focused? Type focus in the chat box. I want you to be focused here. So far, you have almost 1 hour, you have stayed back. I want you to pay attention for 5 minutes, please. Okay. Very, very important step. Very, very important step. Okay. So what I'm going to do here is I'm going to go back and share this presentation one more time. We have this 1041. There is something called as Six Sigma table. Okay. For example, I'll give you one example where there are 2 defects in a sample of 100 and 5 areas are inspected. 5 areas means 5 opportunities. Okay. So 5 into 100 is a total opportunity, and you get something called as into 10 power 5, 4000 DPMO. Okay. Now the point here is this. Okay. Let me go into this table and come back into the, I'm going to go into the Six Sigma table and come back to this first. Okay. I'm deliberately moving to this and then I'll go back to the original. Now we found this 1041.67 here. And in the DPMO table, there is a standard table for defects per million opportunities. If you see here 3.1, 3.4, how many of you can see 3.4 here? Type ICS in the chat box. I can see 3.4. And those who can see this 3.4 here, what is the sigma multiple you see there? Equivalent to this. 6. Okay. This is 6 sigma that you see. Okay. This is what is called as sigma. Defects per million opportunities. For million opportunities, not for million products or million units. Please understand this. That is why I asked you to focus on this. Okay. For million opportunities, you make only 3.4 defects. And if you're super clear about this, if this was something which is valuable to you, useful to you, interesting to you, awesome, please type whatever that you felt in the chat box. Okay. Now, so you calculate, you know the defects, you should know what are the opportunities. you should calculate defect per opportunity and defects per million opportunities. And you should use the Six Sigma table to find out defects per million opportunities. Okay. Now, crystal clear? Fantastic. Now I have shown you this table. And now for this 1041, what is the number that you say in terms of sigma? What is the process sigma for this? For 1041? Close to 4.59, right? Okay, now I'm going to share with you something very interesting, okay? Instead of referring to this table, you can actually go through this Excel sheet, and I'm going to give you one function. I'm going to give you one function, okay? Now, if you see here, you see what is called as 3.08. Now I'm using a function called is equal to, okay, I'm going to copy and paste this function in your chat box so that you can, okay, is equal to norm.s.inv, okay? That is what is the function that we use. When you use that function, you will get what is called as short-term sigma value, okay? Now, when the process continues to operate, there will be so many factors that will affect the process. And statisticians have proved that in long term, okay, it will shift by 1.5 sigma, okay? So long term, if you see here, the short term is 4.5 and the long term will be 3 point. So what you get actually will be this, and long term capability will be lesser, okay? So 4.58 is what you get this sigma capability. You should add whatever this function gives you, you should add 1.5, and that is the short term that you get. And over a period of time, the sigma capability will reduce because there will be so many factors that is affecting the process. So the sigma value will come down. So you should always add 1.5 to whatever that you are getting, because there'll be a shift of 1.5. I'll explain you in depth a little later, but I want you to understand this formula that you will get 3.08, add 1.5 to it, and you will get 4.58 as short-term sigma. Okay, you need not even refer the table. You can straight away use this function and get this. Okay, how many of you, if you're not clear about short-term, long-term, forget it. But at least this function, if you're clear, type SC super clear in the comment box. If this function was useful, type useful in the chat box. Okay, because some people will keep looking at these tables, where to locate these tables. You can actually okay. Now, one more time, I will just explain to you what is short-term and long-term for those people who are not clear. Now, the one question I will ask you, suppose if your machine is producing, let us say, some chocolates. Okay, please carefully hear my question. You're buying a machine, it is producing chocolates, and the chocolate weighs 10 grams. And what the variation it has is 9.5 to 10.5 grams is a specification. And the machine gives you consistently the chocolates between 9.5 to 10.5 grams. Is this example clear? Type SC super clear in the chat box. Okay, this example is clear. My question to you is, if you run this machine continuously for a few months or few years, will the capability of the machine increase, or will the capability of the machine decrease? Okay, all of you agree that the capability of the machine will decrease. Okay. Suppose if it has got a sigma capability of 4.5, if it has got 4.5 sigma, okay, here, so will the defects increase or decrease over a period of time? Will the defects increase or decrease? The defects will increase, because what are the reasons why these defects increase? Please put it in the chat box. What are the reasons why the defects increase? The wear and tear of the machine, probably the input raw material changes, mechanical wear, utilization, etc., etc. There might be. So if you see here, when you have a 4.5 sigma, and if you use it for long term, the defects will increase and hence your sigma capability will come down. So statisticians have told that today, if you find 4.5, please reduce 1.5, because in the long term, it is going to deteriorate, and take that as long-term sigma. Take that as a long-term sigma value. Okay, if this is clear, long-term means over a period of time, it will deteriorate. So take that as a sigma value and start working. If it is clear, okay, how many years now? They just say that to be on the safer side, just reduce 1.5, so that you can be very sure that over a period of time, even if it decreases, this will be the sigma value. Okay. Why 1.5? Very good. Yes, always 1.5. Why 1.5? It is how the statisticians have proved. Okay. So if this session was interesting, useful, valuable, fantastic, awesome, please put it in the chat box. And thank you, sincerely, thank you for each and every one of you for having attended today's session. Thank you very much.